which were basically used in your assembly language programming in 8085 microprocessor. Moreover, there are a lot of instructions that have not been taken till this time. I will try to sort out all those instructions that we have not talked till date in probably our next class. So let's start with the counters and time delay, and let's try to finish this first and maybe in the next class so that I am able to give you assignments. So please note down what is a counter. A counter is set up by loading a register with a certain value and using the instruction DCR INR to update the contents of the register. A loop is set with a conditional jump instruction that loops until the count condition has reached. Okay, so basically what it means is that this loop can be set up to have a conditional jump, and the instructions are executed sequentially until and unless the conditional count is fulfilled, is satisfied. So here you can see the flow chart. Please note down this. So in the counter, you have some initial condition, then you have this making you to jump to a particular subroutine, which is basically a kind of a body of a loop, and it updates the count after it going through one set of that loop. So this updated count, if it satisfies the final count, it comes out of it, else it goes back to perform the second loop, which is a sequential set of instructions. So here is the example. Please note down, all of you. This is move immediate comma 15H followed by decrement C followed by J and Z loop. So the loop starts from your second statement and ends in the third statement. So anyone, what does this mean? Sushant. Sushant, are you there?
So we don't have a Sushant in class.
Oh. Okay, Chamanpreet.
Yes, sir.
Yeah. Can you understand what we are doing here? Can you see? Is the screen visible?
Yes, sir. Screen is visible.
So let's start with the first statement. What does this do?
Sir, actually, I missed few classes due to some family problem. So I.
Okay, Rajiv.
Yes, sir.
Yeah, first statement.
Yes, sir.
First statement. What does this mean? What will this do? What will this execute?
Sir, I don't know.
Did you attend last time's class?
No, sir.
Ram Mohan? Ram Mohan? Are you there? Aniket? Aniket? What's happening? Arvind?
Yes, sir. Sir, it's meaning like move data from here. MVI means move immediate. Move the data immediately.
Yes, good, good. So complete. Move data immediate. C comma
Yes, sir.
15H. What does that mean?
So move data immediately from C register, yes, C register to 15H. Move data from 15H to C register.
Okay, you are partially correct. Anybody who wants to further make it better or make it more clearer? Rajiv, or let's talk of the others. Any volunteers? Premlata? So he was partially correct. Yeah, tell me. Volunteers.
Sir, move the data to register C and whose data value is 15H. And
Correct.
then we perform the
No,
decrement.
not 15H. Data is 15. H is the hexadecimal form of digital 15. Right?
Yes, sir.
Yeah.
Yes, sir.
Okay. So okay, now let's talk about the second statement. What does second statement mean?
Sir,
Good.
it is the decrement of C.
Okay, so
Register
initially it was 15, so decrement of C. Good.
And then we will check the condition, and if it is not satisfied, then we will use the
So
jump.
what does J and Z mean? We already talked about. J and Z.
Sir, jump
Jump.
if the condition is not met.
If not zero.
Jump if it is not zero.
What is the condition?
Zero flag. Zero
C is
flag
not
is
zero.
Yes, Sanya. Go ahead. You just check your
zero
previous
flag
notes.
is not set.
You just need to go back and check your previous notes.
Yes, sir. When Z flag is not set, zero flag is not set.
Okay, fine. What is this? J and Z. Jump on not zero. Go to the address specified if zero flag is not set. Is that clear?
Yes, sir.
Okay. So again, we shall be using our previous knowledge. So using the register pair as a loop in a counter. So our registers like B, C, D, E, H and L are 8-bit registers. So when we talk about register pair, we are not talking of 8-bit but 16-bit. So using a single register, one can repeat a loop for a maximum count of 255 times. Can anybody answer why 255 times?
So because 256 is 8 bits and
Good, that's fine. So you got it, right? And why 255 times? Because the first time is already
Zero.
it's already 0.
okay. So if you want to push this limit, either you go for 16-bit microprocessor, which was not existing at that stage, or at that moment or with 8085 microprocessor, which has a maximum capacity of 8-bit, and each register is having a maximum capacity of 8 bits. It could be done by using a register pair. So when you are using a register pair, there is a small glitch. When you are using DCX or INX, as these instructions do not modify the flags. So this issue can be overcome by considering a situation in which the loop is looking for when the count becomes equal to 0, we introduce ORing the two register in the pair and then checking the 0 flag. You can just note down this part. So this is when we are talking about if there is an extension of the loop beyond 255 times. Suppose it is 1000 times. Suppose it is 500 times. If you want your loop to execute, say 400 times or 500 times or 1000 times, then this is a small modulation that one would introduce, that is by ORing the two register in the pair and then checking the zero flag. Please note down, this is very important because you may be using in your programs, different programs.
Goodbye.
हाँ क्या हुआ? Any questions? Yeah.
You're like da 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 da.
What was that? Okay. So please note down using a register pair as a loop counter. So here, now you see, we are talking beyond 255 loops. So please note down, first of all, note down this program, all of you. Aman? Aman?
Yes, sir.
Now let's start with this program. What does statement 1 or first statement implies?
Sir, it loads the HL pair with, sir, constant value of whatever it is given. So like 1000 in hexadecimal to register B.
What does LXI stand for? It's not talking about register B standalone. It is talking about register B and C. Please note down. Please check what you're talking about. Anybody else? What does first statement imply?
So
What does
looting
first
the
statement? Yeah.
looting the 16-bit number which is given 1000H into register pair B.
Register pair B. How register
Pair
is
into
BC,
register
sir,
B.
BC.
Yes.
BC, sir, BC.
BC. So
B.
this
Yes,
is
sir.
Yes, sir.
so I basically is immediately loading the value 1000 into your register B and
C.
C.
then the loop starts. What is the second statement implies?
Say decreasing by one number.
Decrement
Yes, sir.
value
In register pair
is stored in
BC.
your register B by
1.
What does third statement do?
Moving the
Sir,
data
move the
from
data
C
from
to
C
A.
to A.
Okay, good. What is the fourth statement doing?
So using oring between accumulator and the register B. So using or between accumulator and register B or state or logical operation.
So all kind of operation happens only in your accumulator. So it's
Yes,
ORing
sir.
with the B. And what is the last statement? What does this
So go
do?
to specified address. So go to specified address if the zero flag is not set.
So what is specified address means this is the loop. So
Yes,
this
sir.
will continue to execute till zero is not set, right?
Yes, sir.
Yes, sir.
So can you now tell me after first execution, second execution, what would be the result, say after 5 executions? All of you. How many times this loop will be executed?
So 9 times, 10 times.
Only 10 times. What makes you say 10 times? Class?
Yes, sir.
Yes. What would be the result after your loop has been executed 5 times, 10 times?
सर वो रजिस्टर सी में क्या वैल्यू है जो मूव करी है वो तो पता नहीं था उसके बिना कैसे बताया जा सकता है
कैसे नहीं पता है?
रजिस्टर सी में जो वैल्यू है ना मतलब उसका भी तो शायद पता होना चाहिए वो भी तो मूव कर रही है ना थर्ड ऑपरेशन में एक रजिस्टर से दूसरे एक्यूमुलेटर में वैल्यू मूव कर रही है
Yes.
मतलब तो वो तो पता ही नहीं ना तो मतलब वो उसमें स्पेसिफाई नहीं है शायद
नहीं सर, सर आधा डाटा बगल सी से एम कुछ नहीं।
सर सी से ए में एक वैल्यू डालिए ना थर्ड स्टेटमेंट में मूव ए सी तो सी से ए में जो वैल्यू आई है तो उसका तो पता नहीं तो मतलब फिर और ऑपरेशन इस पे हो रहा है तो नहीं पता
बोलो बोलो क्या कह रहे हो तुम, मुझे समझ में नहीं आ रहा। इसमें क्या हो रहा है? When the very first statement, what is the value of B and what is the value of C after the first statement is executed? What is the value in B and what is the value in C?
Sir, 10 in B and 00 in 6 and 00 in C.
So
10 in hexadecimal means 16 in decimal.
the
16
whole
in B.
number, What does H represent? H is what? The same number is represented in
Hexadecimal form.
moment you say H, that means this number is in the hexadecimal form. इसका बाइनरी पहले बनाओ, वो कितना है या डेसिमल में बनाओ.
सर 4096 डेसिमल में होगा एंड
चलो पहले इसका रिजल्ट निकालो किसी में भी हेक्सा में. Suppose this your microprocessor executes this. What would be the answer? Until unless you understand that कि ये कैसे काम कर रहे, then you will not be able to do programming. So this is like starting to program in the hexadecimal. You're just using some hexadecimal values, and you should be knowing all these things. Until unless you know these instructions, you will not understand what exactly is happening.
So 4096 in decimal.
Okay. And binary? And binary?
Sir, 1 and 15 zeros, consecutive zeros from left.
So what happens after you execute the first loop, the fifth loop, and the 10th loop? What is the value that is in A in your accumulator? Yes, Manali, Sanya.
Yes, sir. Yes, sir.
Yeah. Can you tell us what would be the value in your value in accumulator after the first loop has been executed? Sanya, after the fifth loop has been executed, let's do only these two. I think otherwise it will take a long time. And then I need to, yeah, please do it. All of you, please try. Let's just check it out. Do you understand this, class? Do you understand this? What is this ORAB means?
yes, sir.
What does
Now A and B register, we get the output as 1. And as even number of zeros or even number of 1, we will get the output as 0.
So how do you do perform ORing? Suppose you want to find the result, okay? Mathematically. So how would you find, if you have two numbers in hexadecimal form, how would you find the result?
So first I will convert into a binary form, and then for
Okay.
each bits.
That may be one of the ways. Can you do it directly?
No, sir, I don't know the method.
Okay,
Other than
just try it out using binary number. Just tell us the result.
okay.
result for this particular loop. Manali?
Yes, sir.
Yes. So we have already started to use a lot of these instructions that we have talked about in our previous classes. So you should be knowing INX, DCX, ORA, JNZ. Until unless you know all these instructions and what does it perform, you would not be able to answer what I'm asking for. And these are all very simple instructions. The more complicated instructions or the ones which we have left out till now shall be taken up at a later stage. Aman,
Yes, sir.
कहाँ तक पहुँचे? You people don't
So
say.
just performing the or operations.
Yeah. Go ahead, do it. I want the answer after you execute the first loop in toto and then the fifth loop. And the answer would be recorded in register or in your accumulator. Register A, which is basically your accumulator. Ishan,
Yes, sir.
have you been able to complete?
No, sir.
Not yet. I think the strength was around 26. Now it's gone to 20. What happened? Some network problem. Okay, I think if I can have the answer after the first loop, we can proceed further. The rest I give you as a homework or assignment. Assignment I will give you some good problems to execute for you to understand it better. Yeah. Anybody? What happens? What is the result of the execution?
So 1010 in hexadecimal form.
Okay. That is after execution.
First loop, one loop.
Okay. After execution of the loop for the very first time. So this would be the value in your accumulator.
Yes, sir, both.
What are you
half
talking
value
about?
will be in, sir, half value will be in the accumulator and
So
half
what would
value
you
will
be?
in,
What would be the value in the
register B.
accumulator? So your
So
whole
10.
10.
10 will be in accumulator. Yes, sir.
Okay, and
And 10 will also be in register B. So my answer is 1010. So 10 in accumulator and 10 in register B.
so after the execution, it will come back to this loop again because it does not satisfy the condition. Okay, it's not set to 0, so it will come back to this. So there will be a decrement in the value. So what would be the new value here in your register B? What will be the new value?
10.
What will be the new value? What would DCXB do? What is the role of this instruction?
0. So it will become 0 1. After decrementing by 1 to 10 value, it will become 0 1.
Okay, I think I will give you a problem so that you are able to perform this at home, and I think it will get much more clear. So basically, please note down these things. V is for the number of bytes, M is for the number of machine cycles, and T is for number of your T states. So we will be talking about the bytes, the machine cycles. So basically instruction cycle, machine cycle, and T states. In our subsequent classes, we will be giving you complete definition. Okay. Now please note down about delay. So delay is directly related to your T states. So for each instruction, like in our previous example, like this is one instruction, this is the second instruction, third instruction, fourth instruction, fifth instruction. Each instruction is essentially made up of many T states. And this T state is related to your clock cycle. So to calculate the time for execution of a single instruction, there would be a delay that would be introduced or that would be emerging out of it after its execution. So delay is equal to the number of states, as in T states, over the frequency. So each of these instructions that we are talking about uses several T states. Here we have given the example like MVI instruction, which is move immediate. It uses 7 T states. So since your 8085 microprocessor is around 3 megahertz. So the instructions would require 1 upon t. So 1 upon 3 megahertz is around 3.33 microseconds to comply. Class, are you getting this?
Yes, sir.
So sometimes there may be a need to introduce the delay, as we already know that while execution of certain program in assembly language, you can introduce a delay. So one of the examples is, as you can see from the example on the screen. So this is one way to introduce a delay in the loop. So what does the first statement say? It
Move
is
immediately.
move immediate. Yes.
Data FF
to
into C
register.
register.
Value FF in hexadecimal form to your register C. So this will introduce a delay of around 17 states. This means this instruction, MVI. Then you have this loop coming into picture. So what does this second statement in the loop states? This is the starting point of the loop. Says decrement C. So whatever is the value that is being fed into your register C, it would decrease by 1. And this DCR will take another delay of 4 T states. In the third statement, you have J and Z, which is jumping back to the same loop if the 0 is not set. So what does FF represent? FF is in binary form, what is FF? Or in decimal form, what is FF?
So 255 in decimal and 8
Correct.
ones in binary.
Correct. So this will continue to execute till or repeat it up to 25 times. So once the value becomes equal to 0, it will come out of this value in the register C. Suppose instead of this value is 2A. So the first statement is move immediate C, comma 2A. So how many times this would be executed? Plus
42. 42.
So 42.
And we already know that each individual instruction there is a equivalent T states associated. Like MDI is having 7 T states. DCR is having 4 T states. J and Z is essentially having 10 T states. So you can introduce a loop or vice versa. When you are executing these loops, there is a delay that is introduced. So in the very last, I think this is very important. In the very last iteration of the loop, the J and Z instruction will not be executed, will fail. So instead of 10, there will be only 70 states. So there are 10 T states if this J and Z is executed. If not, then it only takes 70 states. So to calculate the delay, we use the following formula. So the total delay is sum total of the delay outside the loop plus the delay within the loop. So we can calculate the time delay for the previous example as following. So for MVI's instruction, which is outside the loop, it is 70 state. But with the example that we have chosen, where the initial value is FF, it will be executed in this format. So 14 T states, 250 times, 255 times minus the last one, which is either you can say 7, 254, 14 into 254
plus 7.
Okay, so why is it 14? 10 plus 4. So either it will be 254 into 14 plus
7.
4 plus 7, which is 11, or 255 into 14 minus 3. Is that clear?
Yes, sir.
So these are the total number of states in the inside loop plus the outside loop. So the total delay is, sorry, so if we go beyond 255 times, like in this example, can you calculate the total delay for this example?
Yes, sir.
All of you? So there is only one loop. So what is your first statement? It is LXI B1000. So this LXI statement takes 10 states. Then you have one loop. This loop starts from DCX B to JNZ, and it performs all these operations. So DCX takes 6 states, move A comma C takes 4 states, ORA takes 4 states. Remember, all ORing and ANDing operation happens in your accumulator only. So what does this statement mean? Anybody? ORA B? Class?
So ORing the data in accumulator with the data in B, register B.
With the values that exist in your register
B. B.
Correct. And that would take how many T states? 4 T states. So all of you, if this value is
So 4096.
all of you, please try, all of you. And suppose you change another value. You change from 1000 to 1010. Find out the answer. Mansa, you there?
Yes, sir.
Okay. Arvind,
Yes,
are you
sir.
calculating? Yeah.
Yes, sir.
Aman,
Yes, sir.
हो गया?
No, sir. Sir, I have calculated the T delay.
Remember, you need to finally calculate in terms of the time delay. So time delay is related to the frequency of your microprocessor. What is the frequency of your 8085 microprocessor? It is ranging from 2 to 3 megahertz. So what is the relation between time period and frequency? It is Dhirendra. What is the relation between time period and frequency? Dhirendra is not there. Now I can see only 18 students. Where are the rest? I think they were 25 in between. Samatha?
Yes, sir.
Have you been able to calculate, say, for 1000 and 1010 values, the total delay? Tarun? Maybe there is some network problem. Mansa, I also want to have today's attendance. I don't know why. I would like to know who all came or probably who all did not come. Just send an email of who all did not come.
Sure, sir.
Sir, 247 T delays.
TDS? T states. I didn't catch you.
Yes. Yes, sir,
So-
247 T states.
So you need to calculate the overall delay. So here you are having the delay due to the outer loop, and this is due to the inner loop.
Yes, sir.
So first of all, you need to calculate the overall delay, which is sum total of outer loop plus the inner loop. And then once you know the overall delay, you need to figure out
So 24 T states delays are inside the loop and 10s are outside, and there will be 10 cycle. So 24 into 10 minus 3, and on the last one 3 will be directed last step and 10 will be added, so it is equal to 247 T states.
only 247.
So for 10 steps
10 steps.
from 1000 to 1010.
No. I didn't say for 10 steps. I said for two different situations in which you change. In the first case, you have the same value 1000, and in the other case, you have value 1010. Okay, just leave the second part.
Sir, 0.327 seconds आया in case of 100H. In values, it's T states, it's 3,200. So 98,311. Total T states were 98,311.
How did you
And
calculate? You have all got it wrong. Please calculate again.
sir, 24 into 4096 minus 3.
You don't have to just go through it once again, and then I think.
Sir, it's 98311. 98,311 T states.
How did you get that?
Sir, 24 into 4096 minus 3 plus 10.
So first is outer loop. Okay, let's talk of this example. Huh? So the outer loop is having how many states? Because it would be only executing once. So we are only talking about 10 T states. Because LXI instruction takes 10 T states. Then the inner loop. So the inner loop would be executed 24 times, or 409, sorry, 24 is what? 24 is 6 plus 4, 10, plus 10, 20, plus 4 is 24. So this would be executed, since the value is 1000, it would be executed 4096 times. Hello?
Yes, sir.
Is that clear?
Yes, sir.
And in the last stage, since the value is, this would not be executed 10 times, it shall be only executed 7 times. So this would be 24 into 4096 minus 3. So this is the inner loop, 98,301 plus 10, which is how much? 98311 T states. Yes or no?
Yes, sir.
Yes, sir.
So how would you determine the delay?
Sir, by dividing with the frequency of the microprocessor.
Well, let's
that is
take the
3.
frequency, either take it 2 megahertz or 3 megahertz.
Sir, I took 3 megahertz and the answer is 0.327 seconds.
Yes. How about the rest? I think I have not checked it, but you must be right. So after you have done this, what I had suggested to you students is change the value. Change this value to 1010, and then let's see what's the answer is. Class, all of you please perform this. Chamanpreet,
Yes, sir.
हो गया?
No, sir, doing it.
Samatha, I think some students who had logged in before are either not able to log in again or have logged out, or maybe logging it at a later stage when the class is over. Just 5 minutes are left, almost less than 5 minutes are left. Manas,
Yes, sir. Yes, sir. The calculator. Sir, कर रहा हूँ sir.
Sanya, Aman,
Sir, So 98695 T 98,695 T states and in time 0.328 seconds. So
So give the answer. So isn't that big enough? इतना छोटा सा काम करने के लिए, what is the time that you're talking about?
0.328 seconds.
So 0.328 second is for such kind of calculation. So your processors in the 1970s, which or mid of 1970s, was very slow. This would also help you to know that just for executing these many instructions, it used to take so much time. Again, now if we talk in terms of the full capacity, suppose you are talking about full capacity, what would be the full capacity? Here, instead of this value, it is say FF, so not even full capacity, almost full capacity. Like let's talk about FF AB. Let's take this FF AB, then calculate FF AB, almost full, or FF AF. How much time will it take? Or how much delay will be introduced? I'm already in the class. I just call you after 5-10 minutes. Yeah, I'm in the class. I will call you after 10 minutes. Manali?
Yes, sir.
Aditya, Sai Kamal, are you able to figure out?
Yes, sir, I'm calculating. Sir, I think it's 5.183 second.
5.183 seconds for what was your initial value?
So T states were very large. I mean,
Huh?
so a number of T states are coming out to be 1570831, like 1 lakh 15,70,831 T states.
No, but this is when you're taking, what is the value you're taking here?
FFAB. So you said FFAB, right?
Okay, okay. So how much delay is being introduced?
So 5.183 second.
So nowadays you see things happen so fast.
Yes,
right?
I think. Yes, I think.
So when we are talking about mid 1970s, where most of us probably may not have, so we were not even born at that stage. So at that time we had processors which was so slow. So that is why it needed, to be improved upon continuously.
So today it will be, I think, 5.1 millisecond. So it's gigahertz.
Or you can calculate. I mean, like just check out the speed of your processor that you're using in your desktop or your smartphones. Just check out. But remember, these are like having many cores. So the whole technique is very different. But still try to figure out.
Yes, sir.
The whole concept of core and architecture is still not clear. But suppose if we are not talking about core, but what is the frequency of operation? Say in your smartphone or in your laptop, what would be the value? We can just check it out. We just check it out.
Yes, sir.
That is why it's very important for you to relate with the present day systems. So there has been an enormous improvement in all the IT technology, not only in terms of its throughput, latency, its computing power, its the power requirement, and so on and so forth.
So around 0.8 milliseconds.
Now this is a different answer. This answers for which question?
Sir, for 1.8 gigahertz microprocessor that we are using in our laptop, so for that, the delay for FFAF
Okay.
data.
Okay. But our processes are doing far better than what you have just told us. So it is using all other different types of technique other than this technique. This is just by improving upon the frequency of operation. So there are definitely new versions, or we are using new techniques and architecture. So we are actually using you're talking about desktop computer, or are you talking about your smartphones?
My laptop, sir. Yes, sir.
Laptop. So that must be having dual core, quad core, or multi core kind of a processor. So it is further enhancing the overall improvement in the delay because of the introduction of these core concepts. Is that clear?
Yes, sir.
Good. I think I don't know what has happened today. There were generally around 25 students, and some of you did not return back. So I need the attendance of those who did not come at all. And what happened to these 4-5 students? Whether there was interconnect problem or something, or they didn't. Okay. Thank you for the class, and I think I will try to finish this. I'll take some more examples, and getting into concepts of nested loop and subroutines, and try to finish with this, and then also give you those instructions that we have still not been able to cover. We will try to cover them. Some of them are a bit more at the higher end, and then I will give you an assignment by probably this weekend, so that you are well prepared for your midterm exam. So I think by this weekend, so are you students being given any preparation time before your midterm 1 examination
No,
sets?
sir.
Huh? Yes or no?
No, sir.
So you will be having class till what? Till which day? Which date?
So till last day before the exam starts.
So when
there's
is
no
your
gap.
exam?
So
When is
it was told to us that 4th October, but no so it was just the tentative dates. So we were given the
Please
data
let me
sheet.
know. Please let me know the dates when your examination starts, so that we can prepare accordingly.
Okay, sir.
Okay.